Hi, can you all hear me? Cool. This is my presentation about firmware updates for Linux. So, who am I? I'm Richard Hughes. I work for Red Hat in the desktop team. I've worked on open source stuff for about a decade now, and in Red Hat for about 6 or 7 years. I maintain a few different bits like package kit, colord, upower, FWupd, upstream glib, GNOME software, GNOME Power Manager, GNOME Color Manager, and sort of do drive-by fixes to quite a lot of the GNOME and desktop stacks. And this firmware thing is kind of the result of something that happened to me. A few years ago, I got a laptop from Dell, and the suspend would work most of the time. Like 9 times out of 10, it would resume fine. 1 time out of 10, it wouldn't, which I kind of put down as a kernel bug, but wasn't serious enough to investigate. And the USB 3 controller would most of the time work, and sometimes would cause a hard deadlock of the system, which again I kind of put down as Linux being not awesome, some sort of kernel bug that I couldn't debug and couldn't find the problem for. And then talking to the Dell engineers, they said, we fixed that in a firmware update years ago. So I looked on the Dell website, and sure enough, there was 7 or 8 firmware updates I hadn't applied for my laptop, one of which fixing the resume issue, one of which fixing the USB 3 issue. So if a technical guy like me didn't realize that this firmware update would fix my problems, the end users just haven't got a clue. So if we actually realize how to find a firmware update, usually you have to identify your hardware very specifically. So the same physical NVIDIA graphics card that looks identical to a different one could need a different firmware because it's using a slightly different chipset or a slightly different memory speed or something. So actually finding out what hardware you've got so you can find the firmware update is really hard. You might have to take the computer apart and actually physically look at the label on the PCB. You might have to dig around on the vendor's website, which might have gone out of business in the meantime. So actually finding out what hardware you've got and if it supports firmware updates is kind of problem number 1. Second problem is actually applying it. Like this is my HP monitor, which also has a firmware update. And it only has, so if you're like typically, it will have a Windows executable, just here for Windows 7, which is kind of hard. And sometimes if you're lucky, you get Mac OS as well. Now, if the vendor's being super charitable, they might provide you with a Linux download as well, which is either a statically linked, non-free executable that's doing God knows what, or they might provide you with a 1.44 megabyte floppy image. Now, I don't know about you guys, but the last time I had a machine with a floppy drive was several years ago, and even if you do the trick where you DD it to a certain format and strip out a header, you can put it on a CD ISO. But again, I've only got one machine with a CD-ROM drive nowadays, and so even that's kind of hard. And so for my last firmware update, I had to strip off a header using a hex editor, DD some random file to my hard disk, open up grub.conf and do some god-awful command. And bearing in mind, most of these commands that you're running is using non-free code that probably would brick your hardware if you got it wrong. So kind of, if it's hard for Windows users to find this stuff out and apply it, it's somewhat easier for Mac OS because they control the hardware more than we do. But for Linux, it's just almost impossible. So we're in this situation where we're resorting to USB disks and USB floppy drives and usually just not applying the update at all because it's just too much hassle. And I guess one of the problems also is the update description. Now, a lot of the vendors will give you some kind of update description about what the firmware fixes, but most of the time it's rubbish. It's either hiding key details for either business reasons, they don't want to admit that something's their fault because they don't want to be sued into oblivion. They don't want to pay technical writers to write the content so users can understand it, and so they just get some BIOS engineer to put something in American English that people who don't speak English will have 0 chance of understanding. And other times they're using technical words like AMT and WMI, which most of the people in this room will understand, but I can assure you most people on the planet don't know what any of those letters mean. And so we have this like triplet of problems where we don't know if we can get an update for our hardware because we don't know what hardware we're running on or if it supports updates. When we do find an update on the vendor website, we don't actually know what it's fixing and if it's going to fix our problem. And then even if we do find the update, we might have to do something drastic, like install an obsolete version of Windows to actually flash the hardware. And so it's kind of no surprise that nobody really bothers doing this stuff. So at least from a Linux point of view, we suck at this stuff, you know? Like if I'm a 10-year developer for Linux who can't flash hardware on my computer to fix bugs that make it crash, well, what hope have real end users got of doing this stuff? So when I talk about firmware, most people think of their system firmware. Now, I guess most of you will be familiar with BIOS. BIOS is like your system firmware for older type computers, responsible just really for bringing up all the hardware on your computer so that you can run grub and actually boot an operating system. Now, BIOS is awesome in the fact that it's been around for ages and it doesn't do an awful lot, which means there's not an awful lot that can go wrong. And usually with BIOS, the things that are going wrong with the BIOS are the new hardware features, things like PCIe, link power down, ASPM type stuff. So the new features tend to go wrong rather than the older features. But because BIOS is so simple, even if it does go wrong, you can reboot your computer. It's not like it's doing networking or anything too critical. Most of the BIOS settings people know how to use. And so the number of things that are fixed by firmware updates for BIOS after about the first year of the hardware release is almost zero. Because the first few months of the hardware being released, the vendor will find loads of bugs, issue a flurry of updates. And then after the hardware is about a year old, it's EOL, and there'll be no more updates at all. So then UEFI came to the party. Now, for a multitude of reasons, BIOS isn't great on today's hardware, and so Intel came up with an EFI specification, which is now a universal specification but across vendors, where you can have a complete pre-boot environment for running networking and graphics card drivers. You can do loads of cool stuff with UEFI, like provisioning and networking and stuff. But now all of a sudden, this UEFI thing is its own OS. There's networking drivers, you can do PXE, you can do, you've got full access to the hardware because you've got the Intel ME management engine, which has got control over everything. So all of a sudden, this nice little self-contained BIOS that couldn't cause too much damage, you now have the possibility of security errata for your system firmware. You have the possibility of remote code execution with full control of all the hardware on your computer through not applying a system firmware update. So if you're like a bank and you have different compliance issues, all of a sudden it's a big deal. Now, the other thing we kind of care about is removable devices. So things like iPhones, oscilloscopes that support updates, all the random USB stuff you get that it seems every electronic gizmo has a USB connection for power and also firmware updates. And about 10 years ago, the USB consortium built this thing called DFU, and they spec'd up a whole specification about it. And it stands for Device Firmware Upgrade. And it's a specification which basically says to a device, switch from your normal mode of operation to a special bootloader type flash operation called DFU mode, where you can put a new image onto the device, verify it, and then boot it back up into application mode. And it's a standardized API that maybe 30% of vendors use. If a vendor uses DFU, you get free drivers in OS X and free drivers in Windows, and until recently, not awesome support in Linux. DFU devices, when they are written to the specification completely, are awesome because you can automatically do the firmware update without the user having to do anything. But most vendors, either through a full sense of security or not quite reading the specification carefully enough. Usually support like a hybrid DFU scheme where you have to use various different vendor extensions to do the flashing or to apply different memory maps. It all gets a bit vendor specific. Also, vendors sometimes forget that there's two halves to the specification, and so it might be that to turn a device into this upgrade mode, you might have to hold down like the home button for 5 seconds while you turn it on, which are sort of quirks we have to deal with when dealing with devices. DFU also has the problem where most USB devices aren't high-power ARM devices. Some are, which is awesome, and you can do like proper public-private key firmware security. But most are either like Atmel or PIC microcontrollers, where you just haven't got the processor or the memory, RAM or ROM, for doing a proper public-private key security. So we do support just crypt modes, like we could support XT over DFU now. Now you can, for the last 10 years, you can update hardware using DFU util, which is like an old utility developed for OpenMoko. But it's very much an old Unix type command line. It's not a library we can use. So I spent a bit of time writing libdfu, which is a G-object introspectable library used by the later bits I'll show you in the presentation. So we can do reliable, safe upgrading of removable devices. So what did we come up with? We needed a framework to tie all this stuff together, because we've got all this metadata that we need to acquire from vendors. We need the way of applying the update, and we need a way of notifying user space components of any changes. So I built a daemon called FWUpd. FWUpd talks to various different subsystems, it'll talk to systemd for scheduling offline updates. Some hardware can only be updated when it's not being used. Other hardware can be updated live. Other hardware can be updated only before Linux is booted, so you have to do it in a pre-boot environment. So we have to talk to systemd to schedule that. We watch the sysfs for hardware that comes and goes, so we can notify any GUI software of firmware that needs updating. All the metadata, which is provided by the vendors themselves, is stored in a standardized format called AppStream, which is an XML description of what the firmware applies to, what hardware itself applies to. And I'll explain more about that in a minute. We use something called, so for UEFI, for a long, long time we've been able to install random system firmware. But we haven't had a system where the firmware could report to user space what hardware have I got installed that supports runtime updating. So using UEFI, you could update your system firmware, which is the obvious one. But you can also update option ROM on things like, InfiniBand network cards or GPUs, etc. And UEFI supports that as well. We need this table called ESRT, which is an extension to the UEFI standard. We need that from vendors before we can find out what hardware is available on the system to support updating. Luckily, for Windows 10, Microsoft made ESRT a requirement for their WHQL requirement. So now more and more vendors have kind of realized that actually they have to do this as well. So we get the support for free. Now I've kind of put in the thing a vendor provider. We support by default the UEFI support for system devices, like PCIe type devices, and system firmware. And we support libdfu for removable devices, USB devices. But there's still a ton of hardware out there that does something vendor. Like, for instance, like ColorHug 1, I built a vendor-specific HID protocol for updating. And so I've had to write a ColorHug-specific provider for FWUpd, which really means it provides FWUpd with what hardware is installed, if it supports updating, what version it currently has, and provides a mechanism for actually blitzing the binary file to the hardware itself. Now, there's no reason why you couldn't write a BIOS provider for the legacy BIOS rather than use it if you have a system that's not UEFI compliant or doesn't ship with that BIOS. There's no reason why you couldn't write one for BIOS. The issue is when you update a BIOS, you normally either do it over SMI or ACPI. And if you get it wrong, even if you get the timing slightly wrong, you can brick your system pretty easily. So most of the vendors I've talked to were quite hesitant to add BIOS updating to this new framework compared to UEFI updating, which is a standardized interface that they can use quite safely. So there's nothing stopping random vendors adding random code. The only proviso it has to be free software. We can't accept some random 2 megabyte statically linked blob which does unknown things on your RHEL server running on some bank infrastructure. So now we've got this nice daemon that's providing us with changes and it's kind of insulating user space from all the grotty hardware details. We've got a command line tool called FW Update Manager. Now this is primarily used for, I guess, geeks and people scripting stuff. So if you're running like a 10,000 nodes render cluster, you don't want to be installing FreeDOS on floppy disks and going around pressing enter with a VGA monitor attached on every single server. And so you want to be applying this stuff automatically, like using something like Satellite, or fingers crossed in the future, we'll have something like Cockpit driving this thing as well. So it'll be a point and click. We also have clients like GNOME Software talking directly to FWUpd, which means we can provide a very high interface for providing the user an easy way and a safe way to install system firmware offline and also for removable devices. Yep, and that's all I want to say. So the biggest challenge I've had in the whole project isn't assembling the code. The code was pretty easy. Assembling all the pieces and writing libraries and reverse engineering hardware, that's the easy bit. The hard bit was getting the vendors on board. So I wrote this web service called the Linux Vendor Firmware Service, the LVFS. And with the LVFS, it basically allows the vendor to upload firmware files, which we can check and validate or verify or QA. And then securely, we can repackage them and send the metadata to clients and firmware if the hardware matches. So typically, someone like Dell would have 2 accounts on this. They would have a low permissions account where for their firmware engineers. So, like most OEMs don't actually produce the BIOS firmware themselves. They rely on an ODM, original device manufacturer. So even if Dell wanted the firmware to be open, the ODM wouldn't let them because they'll be underneath the person selling the hardware itself. And so the ODM would log onto the system and upload firmware, which then another more privileged user could log into this system as a QA user, check out the firmware, check that the description's up to snuff, check that the firmware applies properly, that there's no user interaction required, and that the firmware fixes the bugs that it says it does. So with the LVFS, the vendor uploads a cab file. Now, one of the compromises with Microsoft, we were originally working with Microsoft on a shared specification for the metadata required for this, which was going really well when I was talking directly to Microsoft engineers. And for various legal and competitive business reasons, we kind of had to cut those talks short. So we decided to ship it anyway. Since launching the LVFS, we've provided 100,000 downloads of metadata to unique clients and provided over 1,000 firmware files, which I think is not bad considering it's only been running about 4 months. So far, we've had about 6 or 7 vendors testing the system, which was another major source of frustration. Loads of vendors initially piled on the LVFS system, trying out the different things, trying out how the distribution system worked. But none of them had the guts to kind of go public. They wanted to stay secret. A lot of the vendors, ODMs and OEMs, are very secretive companies, and they don't want to release certain things because it could impact other things. And it's all a very secretive world. And so Dell were the first one to come out and say, actually, yeah, we've been testing this for 6 months. We're confident in what it does. we like the system, we think it's useful, and they released a press announcement a couple of weeks ago basically saying that all their UEFI hardware from now on, their laptops and their tablets, would now be supporting LVFS at ship date, which is just an awesome thing. So Dell announced that one day, and the next 2 days there was a flurry of emails from the other vendors who were testing the system. It prompted them into some sort of action. So I can't announce anything yet, but just you have to trust me that there are other vendors that are like this close to doing press announcements. The LVFS is kind of a political hot potato inside Red Hat because it's essentially hosting non-free blobs. And so hence it's hosted external to Red Hat on an OpenShift instance. One of the reasons I chose OpenShift was that at the moment we're only handling, I don't know, maybe 2,000 downloads a day. So it's not a huge quantity of downloads. But in Fedora 23, we added this as kind of like a secret feature. In Fedora 23, if you go onto the updates panel in MSDOS software and manually click refresh, you get the distro metadata, and you also get the firmware metadata. And then for some people, there might be a little item that pops up saying you've got a firmware update available. Now that was like a soft start to the system because we didn't want to enable the automatic mode and just be besieged with 100,000 connections a day because we didn't know if the service would A, be a success with the vendors, B, scale, or C, even be interesting to end users. Because without the vendors, it was kind of useless to have all this data and CPU stuff going on. So yeah, now Dell are on board, and other vendors are sort of super close to making announcements. For Fedora 24, we're enabling it as an automatic thing. So rather than having to manually click the refresh button in the updates panel, it automatically happens on idle bandwidth. When the session's idle, it'll download the metadata. If your hardware is lucky enough to be new enough to be supported, you'll get the notification about firmware updates and be able to install them offline easily. So yeah, that's the cool bit. So if you're an admin, you kind of care about the LVFS stuff, the low-level things. And even if you're a slightly paranoid hacker, you might care about the low-level things. We added a feature where we can scan and interrogate firmware on your system that doesn't even support firmware updates, which might seem an odd thing to do. But if you've upset government agencies with three letters, it might be that the firmware on your system could be replaced without you knowing about it. So we support a verify option, which will take like a hash of all the firmware on your system, which will then, if you rerun it and the firmware has been subsequently changed, it will then alert you if it's been changed, which fingers crossed will be because you've updated the firmware manually yourself, but in other respects might be less awesome. Most devices support offline updates, either through systemd or the pre-boot environment. When you actually schedule a UEFI update, it actually happens before you even boot grub. So that means that inside the firmware package itself is actually an EFI executable itself, which kind of scares people. So the idea from a vendor point of view is you take the cab file. Now the cab archive wasn't my choice. It was like a compromise when we were working with Microsoft. So the cabinet archive inside would contain like the INF file. It would contain the cat catalog security file, the binary file itself, which would be an EFI executable. And there'd also be the metainfo XML, which is the high-level translated description for end users. So you've got all this data inside the cab file. Once that file's been uploaded to the LVFS, we'll break apart the cab file, we'll verify it, we'll sign it with the LVFS key, we'll extract any metadata and provide the metadata to be downloaded to end clients. The actual download of metadata is done over SSL, which is like a first layer of protection. The metadata is then signed with a detached GPG signature, also from the LVFS automatically. vendors have to log into the system using a username and password. Some vendors, like the ones with the clue, know what GPG is, and they also have a GPG signature that they sign the firmware file with. And then once it actually gets onto the system, assuming the hardware matches something in the metadata, we download the firmware, which has an internal GPG signature, which we then check against the LVFS one. And then we deploy the firmware. The EFI binary will only run if the EFI binary has been signed by the vendor that built the computer. So it's like triple layer of security, because a lot of people are quite scared with the idea of updating something as critical as system firmware as easily in the desktop by just clicking an upgrade button. There's like 3 layers of security. So when you actually get an update, you can have a really high-level description. Okay, maybe the description here is not the best in the world, but you can have real descriptions that say, this fixes the occasional hang on resume. So it's designed as a high-level, user-visible, translated description. So this is all done using the upstream data that's provided in the meta-info file provided by the vendors, which they can also edit on the website as well if their firmware engineers aren't doing an awesome job. So this provides like a translated product name, translated short description, translated long description, information about where the updates come from, if it's been signed by someone, the license it's under, the download size, the installed size, etc. So because of the slight breakdown in comms with Microsoft over the collaboration, I would be amazed if they didn't roll out exactly the same system for Microsoft Update in the next year or so. Because all the information, the vendors are now providing this information in this file format, which we've almost agreed on. So I'd be very surprised if we didn't see exactly the same thing in Windows Update, probably end of this year. But you can see it's a very high-level thing in the UI. Now, I mentioned about DFU devices that don't do the right thing. A lot of device hardware, say I have an oscilloscope at home that requires you to hold down one button at the back and one button at the front whilst you turn it on to go into firmware mode, which is it kind of talks DFU when you do this, but it's not really in the spirit of DFU. You have to physically put it in this special mode. So I'm going to say that's more secure. I think it's because they misread the spec. So I neutered the color hug device to take away the runtime DFU component, and just showing that we can input localized descriptions of how to put a specific device into a mode in the upstream data itself. And we can also include a screenshot here as well. So the screenshot will be something like just a diagram that shows the user what buttons to press if it's slightly unclear. I didn't include it in here because it's fairly obvious. But you can see it's a very high-level thing. And for DFU devices that are removable, you can mostly update them online, and so you can just do it straight in GNOME software without having to reboot or anything else. Now, I've deliberately left loads of time for questions because this stuff scares a lot of people, and a lot of people are quite worried about the security implications and the vendor issues around this. So I'm kind of asking this. If anyone can ask any difficult questions, I'm really pleased, go for it. Thank you.
Can you roll back now?
So yes. So the question is, can you roll back? So UEFI allows the provision of rollback. We don't allow it easily in the GUI, but we do allow it in the command line. There is a slight wrinkle in the ointment. Is sometimes when you update system firmware, you might update the Intel ME engine, which means you can't go back to the old version. And so there's a field in the UEFI firmware which says the previous version has to be at least this. So sometimes if we update between, say, 1.0 and 1.3, we can only update go back to 1.02 or something. So we can't always go back to exactly what we had. For DFU firmware, yeah, we can always downgrade. There's no limit at all on going backwards. But yeah, it mostly depends on the provider other than that. So in general case, yes, it's absolutely fine. We just can't do it in the GUI. Go on.
Do you have to have the updated firmware from LVFS server, or do you save the previous firmware with the update? How does it work?
So the downgrade will only work through the command line tools if the original version is available on the LVFS. We can't. There's especially with UEFI, we're not allowed to access the binary blob from user space. We can only do that in the pre-boot environment. And so we wouldn't have any way of saving it for recovery, so to speak. Most BIOSes do include a split memory map, so you can have like old version and new version, which is a really good way of doing it, because if that one fails, you can always go back, it'll automatically go back to the first one. Not all BIOSes do that. So I'd love to be able to say I'll recover it manually, but it really has to be up to the flashing program itself. Because some of these vendors like Dell have done a really good job with their EFI binary, so that it's like a well-structured update that's going to do safe things in sane ways. Other vendors have taken their existing SMI-based flash tool and just stuffed it in an EFI binary, which is going to have exactly the same problems of timing violations and hardware access that the BIOS update mechanism did. So yeah, no names mentioned, but yeah. Any other questions?
Does the vendor upload web app thing use 2FA if it doesn't show it?
So the question is, does the website use two-factor authentication? No, it doesn't. I think it probably, in an ideal world, should. I think most vendors have a hard enough time with the password and username. So most vendors are like, well, can I have a password like password so I don't have to remember it? And I was like, no. 2 or 3 understand what GPG is, but have no idea about how to do key security. So I don't know if that's a liability or a good thing. Two-factor authentication might be opening the gates to hell. I wouldn't be against adding it if any vendor wanted to do it. Like we've had one of the independent vendors was asking, they actually asked for the GPG feature, which is awesome. I don't think they've got enough clue for two-factor.
Google helps to like popularize the idea of
Yeah, I think when you think of like these cool like web companies like Google, and you think, yeah, they know exactly what they're doing. They're on top of the security thing.
Well, I mean, they like frustrated normal users that it is.
Yeah, but I wouldn't call a firmware engineer a normal user. Just from the update descriptions that you read, you think these people are like borderline sort of psycho, the crazy people. Any other questions?
So I'm thinking like hypothetical worst situation. In the old days, let's say I have a T440S laptop. If there was a problem with the firmware, not many people would maybe hit it at once. But what happens if a bad firmware update is sent out and all of a sudden thousands of people's systems are bricked? Is there anything that we could do?
So
it's very scary that we're now being involved with
So
this level.
I don't. So the question was basically, now we've automated the whole system. How do we stop it going wrong very badly, very quickly?
Yeah.
So with the old system, is if the vendor uploaded a bad firmware to the website, very few people would find it, very few people would be affected, and they'd have a long time to fix it. So with the LVFS, we kind of have like multiple user logins. So I've kind of told the vendors they need to have one low privileged account for uploading for like firmware engineers, and they need a QA account. If they don't test this stuff, the deal is with the LVFS, if they break everyone's systems, I kick them off the LVFS, because it's a massive amount of trust you're putting in a vendor. Because you're saying your old system that wasn't automated is now automated. We can blit it to 1 million computers in one day. But if you break it, you're going to break it hard. I'm hoping that the risk of their reputation would be enough so that they actually QA their updates, or that they have some sort of, like I said, the dual BIOS system, where if one was bricked, you would go back to the old one. It is a concern, and it is a point of responsibility. One of the things that kind of ties into this, we're not sure what to do with the LVFS. We're not sure whether to make it a Red Hat system or not. Should it be something that's housed inside Red Hat? Does that give it some sort of stamp of approval that the firmware has been checked by Red Hat when it really hasn't? It's just the vendor that's been doing it. So it's a kind of a sticky, do we want the Red Hat stamp on it or not? And that's way above my pay grade to decide. Another question.
So I have kind of two, just as a quick follow-up. What if you after upgrading, check to see if it's successful or not? Obviously, you can't really check if it's bricked, but you can say like, hey, this was a successful update, so at least you know that it worked enough to get all the way up to the network.
So yeah, so we do. So when you do a UEFI update, you do actually get information from the first boot of the new firmware, whether it booted correctly or not. So if it didn't boot correctly, we'll actually show a notification on first boot of probably the old firmware that the update failed. There's not so much user kind of description we can give there. We normally give like an error code and a fairly cryptic error because that's all we get from the hardware. Is that kind of answering the question?
Well, I meant like it could report the success rate, so that way.
So yeah, that's something that Dell actually wanted. They want to basically say if I send a firmware update out on the LVFS and it's failing on say 1% of computers, can we get a failure rate on as a graph on the LVFS? My response to that was, unless it's going to work 100% of the time with no user interaction, it probably shouldn't be sent as an automatic update.
Right, but this could prevent at least thousands of.
Yeah, so that's a valid point. So the question would be basically, if it was not working for the majority of people, automatically pull the update, and that's a good idea. There's a slight privacy implication, which is a slight worry, where that you'd be sending your system version to the LVFS, which would be identifying systems that were insecure if you ever knew of a known security vulnerability. So there's a slight privacy issue there, but it's not unfixable. We could send a hash or something.
And then also, earlier you mentioned that you can actually just check public firmware versions and get like hashes. That way you know if it's if you've been updated by someone else.
Yeah, so I guess, I don't know if I can do a demo or not. Let's see if this.
Do you like save that to the log and check against it or anything like that?
Yeah, so we save it to both the journal and as an XML file on the system. Let me see if this works. Never do an unplanned live demo. So we have FWUpdate MGR. So if I make that bigger. Yep, just trying. How do you do it? Control plus. Right, FWUpdate. So you can see here I've not done any checks. Basically all the firmware that I have, if I actually plug in a bit of hardware which does have a signature. So if I just plug in a color hub device. So if I now do, go away. So if I now do FD update manager, you can see that I've got a color hug device I've just plugged in using DFU. You can also see other stuff I've got, like not useful, like a camera. So the camera is a good example because I can't actually update the firmware itself on the camera. This is the internal camera in the laptop, but I can return the hardware itself and also the version of the firmware. So I'm aware if it changes or the version itself. So if I then verify something that I know has got a valid firmware, so it's probably got development firmware on it. But yeah, so the idea is that if you have a device with firmware that you've got from the LVFS, it will display a valid checksum because it has the LVFS data already. And if you haven't got, say for instance, the camera, you'd have to actually physically do something like this, which would then store it locally and also record it in the journal, which would then go through the hardware, etc., and just process all the ROMs, create the checksums, then it would verify. Does that make sense? Any other questions quickly? Go for it.
So, how do you identify the vendor who update is the real vendor? Like, it's easy to identify that something for Dell comes from Dell, but what if it is some unknown vendor from China who makes USB webcams, makes millions of them,
Yeah.
and he doesn't update firmware for some other company who makes other USB cards, but he breaks all those others.
So the question is really, how do we identify that A, the vendor is who they say they are, B, that they only update their own hardware, and C, that they don't brick other vendors' hardware. So with when you look at the list of devices, each one has a GUID, and the idea of the GUID is that it uniquely identifies hardware. So if you have 2 ARM chips that require 2 different versions of the firmware because of different memory timings or something, they'd have different GUIDs. Vendors are only allowed to update things that have the GUID listed in the upstream metadata, and so you kind of restrict vendors what they're allowed to update. So a Dell update wouldn't be allowed to update a ThinkPad firmware. So that's kind of like the first way. The harder social thing is when a new vendor comes to me and says, "Hi, I'm so-and-so from some random Chinese company. Can we upload firmware?" How do I know that A, they are who they say they are, and sort of B, how do I know that it's legitimate because it might be someone rogue in the company, so even if the end of the email address matches the company that they say they want to do, how do you know it's not a rogue employee wanting to backdoor whatever? And long story short, we don't really. We kind of have to use the social stuff of ringing phone numbers, talking to people on the phone, talking to managers, sometimes going through legal, because asking someone to get legal sign-off for using the RVFS is a really great way of escalating it in the company so you know that you're talking to the right people. So there's no technical way, really, I think we can do it. I think it's a social problem rather than a technical problem. Any last questions? No, apparently we're all done. If you want to grab me for questions afterwards, grab me afterwards or send me an email. I'm Googleable. Thank you very much. Oh, I forgot your scarf.